The application editor enables teams to define services and their respective infrastructure. This is done by adding a service template and then assigning it to an existing cluster or creating a new cluster. Kubernetes service templates are assigned to infrastructure by specifying a Kubernetes provider cluster. A Kubernetes provider cluster specifies one or more hosts on which to install the Kubernetes agent and any associated packages. In this instance, csap package monitoring has also been included. As applications grow in complexity, csap environments can optionally derive configuration from a base environment. This eliminates redundant configuration elements. For example, if we click on the base OS cluster, you'll notice that there is a host assignment, but the service templates have not been assigned within the current environment. But in the environment view, it is actually showing the assignments. So where are these service instances coming from? If we open up the settings for the current environment, dev, we can see that the environment imports includes the import of a special environment labeled defaults. If we switch to the defaults environment, we now see the base OS cluster with no host assigned, but the service templates assigned. This view enables application teams to modify the service template in one location and potentially update a large number of environments. In this application, switching to the project view, opening up the environments, yields that there's over 21 environments defined for this application, with a default being utilized across all of them. Of course, any of these environments may import the defaults and selectively override if they need it. To add a new service template, click Add Service and then enter your new name. We'll call this service Demo 99. The default service profile is Docker, and we'll go ahead and add a description. By default, the process match will occur using the container PID. So we'll go ahead and leave that defaulted. Switching to the container tab, we have the option of deploying to a Kubernetes cluster or strictly to a Docker container. For this initial deployment, we'll simply define the container and deploy it to a Docker cluster. In this instance, we'll simply use the latest Nginx available and go ahead and add the service. And we see our service is now showing up in the not assigned to a cluster. So let's just go ahead and create a new cluster for the service. And we'll go ahead, add it to a few hosts. And we'll go ahead and add our Demo 99 service to the cluster. After updating a few other fields, we'll go ahead and add the new cluster. And now we see the new cluster assigned to 3 hosts with a single service deployed. So now we can activate the cluster and then perform a deployment. Right now, instead of checking into Git, we'll go ahead and test it first. So we can switch to the deployment view, see our new cluster with a single service template assigned. And so we can select all instances, hit deploy. Note that we could modify the version image if we were testing a new version, and the auto start. So we'll both pull the image and start a container instance. And so the pull of the image completed, and then we went ahead and did the start. Going back to the Demo 99 services now show that we have the container running on 3 nodes. We can also click on logs, and now we can see the container logs. We can switch between the different hosts, so on Dev 3 and Dev 2. We can view the logs also on the host as well as inspecting the Docker container. To do that, click on the Open Logs in Agent Dashboard, and we'll see the same logs on just this one host. We can then switch up to the OS Explorer. Note that the Docker configuration is shown with 5 running containers. Opening it up, we now see our Demo 99 container is actually running. The newly created container can be selected and opened. We can look at the individual fields either through the content viewer or by selecting the individual attributes. It's worth noting that we did not assign a public port to the container, so there's really no way to test the service. To assign a public port, the first step will be to verify that a port is available. To do this, we'll open up the socket listeners and type a port that we expect to be free. There's no connections listening on 7272, and there's no connections on the host. We could run this check on all 3 hosts, or we could use the command runner to run it on all hosts at the same time. For now, we'll just assume that it's free on all hosts. To modify the configuration of the service, we'll go ahead and launch the editor, and then we'll modify the port mappings. The private port will be port 80, which is published by the container, and the public port will use the csap service variable, service primary port. Switching to the packaging tab, we'll go ahead and enter that port. The usefulness of the csap template variables is that it then enables us to use a single reference in multiple locations in the definition. Shown here, the primary port will also be used for the launch URL. So once again, we'll go ahead and update the definition and then activate the modifications. And returning to the deployment tab, we'll once again hit select all. We could do a stop and clean, but hitting deploy will simply be a shortcut. And once the deployment is completed, we can now launch the application to test. So we can select a specific instance and launch it, or with all of the instances selected, we can actually launch all 3 at the same time. So there's 3, 2, and 1. And returning to the host dashboard, we could also open up the containers, select Demo 99, and note we can now see that there is a public port defined that we can click and launch. Another common item frequently edited are the files associated with the csap service. When you select a service instance and open files, the default folder displayed in the Docker container are the / and the etc folder. It might be desirable, however, for teams to bookmark specific folders. In this case, the contents of the message being displayed. We'll go ahead, copy the path, and then we'll paste that path as the property folder. And then, of course, we'll reactivate those changes. And now, with that shortcut added, we can go ahead, open the files, and now we see the updated path. To demonstrate the utility of this, let's go ahead and modify the welcome page. We'll go ahead and save those changes. And now let's go ahead and launch the page again. And now we see the new updated message. The default message is still available on the other 2 hosts. While the deployment today and the editing today focused on using a UI with a forms-based entry, it's important to note you can always switch to the project view and edit templates drawer. So in this case, we added the Demo 99 service, and essentially you see about 15 lines, double and triple spaced, of the entire configuration that we've added thus far. Conversion of a service from a cluster of Docker instances to Kubernetes can be simple as removing the service from the Docker cluster and then adding it to a Kubernetes service cluster. Kubernetes has a slightly different networking policy, so we'll go ahead and we'll select node port for the service type and then add a couple of additional port mappings, and then the same process of activating the modifications, switching to the deployment tab, selecting the cluster where we added the service, and then going ahead and deploying it. It's worth noting that in the output, it clarifies that the Kubernetes spec is being generated. Selecting refresh on the logs will check to see if the container is started. You may have to do this a couple of times. In this instance, it shows that the container has been started and deployed by Kubernetes. And now we could go ahead and look at the logs and the other components on the server itself. Switching up to the OS Explorer, we can select filter by namespace and then look at the pods deployed. And of course, there's our Demo 99 service. In Kubernetes, access to service is handled through ingresses and services. Since we added a node port mapping, let's go ahead and click, and there you have it. We've got our Kubernetes service deployed. Service templates can also use standard YAML specifications. To get started, we'll go ahead and add a service, and this time we'll call it Demo 98. We'll leave the service profile set to Docker. On the Container Specification tab, we'll go ahead and select to deploy using Kubernetes specifications, and then we'll go ahead and specify a file name. So we'll call it the Nginx replica, short for replica set. And then on the File tab, we'll go ahead and create that file. In this instance, I'll just go ahead and use an existing CSAP template, Nginx simple. And we've pasted it in. And now we'll go ahead and add that service. And having created that service, we'll then go ahead and include it in the Kubernetes cluster. With Demo 98 added, we'll go ahead and do the activate and the deployment. So let's go ahead, select Demo 98. One thing to note is that we can verify the contents of our file that we're about to deploy by selecting definition files and then double-clicking to view the contents. Now, one thing in the verification step is that I noticed the container name does not match the service name. Let's go ahead and update the process mapping to use the container name. At deployment time, CSAP will substitute the variable $service name with the actual name of the service. Thus, we have our OS process mapping resolved. Like any other modification of the application, we'll save the modifications, and then we'll go ahead and do the activate. A couple of other items worth noting for the demo service. Because the file being deployed is using Nginx simple namespace, we'll also update the container mapping so that it will match anything in the namespace with any container name. CSAP has flexible container mapping. This is an easy way to get all of the containers noted. Also, container count, since the replica set count is set inside the YAML to 1, we'll go ahead and we've updated that to 1 as well. And so with those clarifications, we'll go ahead click on deploy. And we can note here the use of the search for resource prefix. This will search all of the associated resources that are associated with this service. So if you have one customized on a specific environment, it will use that instance as opposed to the shared one. And you can see those modifications to the locator to map all of the containers found in the particular namespace. We'll click on deploy, and just like that, the namespaces have been created. Now, CSAP does generate a specification with any service templates that were customized. And so in this instance, we actually had the container name set. So in the checked in version, we had the CSAP template $service name. That's been replaced. If we hit refresh on the logs, it will scan to see if the pod's been created. It appears it has, and now we're seeing the actual pod logs. The YAML spec that we deployed actually included monitoring probes, so you can see those probes hitting the Nginx server. And finally, we can navigate to the node and look at the logs, as well as looking at the components that were created as part of the deployment. And you can note the events that occurred as part of the deployment, the config maps, the cron job, and the pod count. Note that of the 3 pods, 2 of them are simple cron job outputs which have completed execution, and the third is an active running container. Now, one thing interesting to note is that shortly after this service was started, it was actually shut down. Clicking on the service history shows that it was killed due to runaway sockets. And that's because in my lab, the runaway socket limit is set extremely low to identify any early violations. So let's deploy it again and increase that limit. To do so, click on Deployments, click on Edit, go to the Alert tab. The default for the cluster is only 10, which means a kill occurs at 20. We'll go ahead and set this to 40 open sockets and go through the regular process of modifying, activating, and then redeploying. And so once again, we can go ahead, look at the Nginx simple service, click it, and note that we're now getting the message from the test service. To modify this, let's return to the application server. Let's open the definition files. And we'd opened this previously, so it was already loaded. And we see here on line 114 where it's updating the index file. So we'll just go ahead and replace that with XXX. We can hit save. Go ahead and update the definition. Switch back to the deployments. And because this is a specification, we do need to manually remove it first. And then we'll deploy the updated version with the updated message. And after a minute, it's actually completed the removal. We'll switch back to demo 98 and now do the deployment again. That occurs pretty quickly, so let's go ahead and launch it. And now we see the hi from XXX.